The new thing that you are going to be learning how to do today is to evaluate powers that have fractions as their exponents. So there are going to be a couple of formulas you're going to need to know. If you have a fraction exponent and the numerator is 1 and the denominator is some number, then a is the base and n is what we call the root. So a to the exponent 1 over n is the nth root of a. A to the 1 over n is the exponent form, and the nth root of a, so it looks like a square root sign, but with an n, or whatever the denominator is, that goes into that little section there, and that's called the radical form. The easiest way to explain this is to think of an example which could be 16 to the 1/2. So that means 16 is the base, and because the 2 is in the denominator, that is a root. The 2 is not an exponent. The 2 is a root. So that works out to be, so you make a little square root symbol, and then whatever that number is in the denominator, you put in that little space there, which is 2, and the base goes under the root sign. So that is actually the square root of 16, which basically means what number squared makes 16. So that would be 4. So a root is sort of the opposite of an exponent. A root means what number to this exponent, which in this case is 2, would make 16. So if it was a to the 1 over n, you are looking for what number to the exponent n makes a. So again, the 2 in this case, or the n, whatever the denominator is, that is not an exponent, that is a root. So in this example, 16 to the 1 over 4, that means it is the 4th root of 16. So we're going to look later what happens if the numerator is not 1, but for now, if the numerator is 1, the denominator makes a root. So that is equal to the 4th root of 16. So it looks like this. A little 4 inside that root, 4th root of 16. So you are looking at what number to the exponent 4 makes 16. And that would be 2. And I just want to remind you that this is what we call exponent form. So when it looks like that, that is exponent form. And this is radical form. Now, your solutions, you don't have to put it into radical form as part of your solution. If you could just read this and say that's the 4th root of 16, so what number to the exponent 4 makes 16, and get the answer of 2, then you get the idea and you don't have to write this step here. So the next question, again, it's in exponent form. If you want, you can change it into radical form. So that is the cubed root of 27. So we are looking for what number to the exponent 3 makes 27. And that answer is 3. So you're really going to need to know all of those exponents on the exponents you are expected to know. because you need to know that 3 to the exponent 3 makes 27, or in this case 2 to the exponent 4 makes 16. After this, I will be showing you how to calculate this on your calculator. Next one is we're going to be looking at what happens when you have a numerator and a denominator. So, as I said, the denominator is a root, and we're going to do that first. The numerator is just a regular exponent. So the denominator is a root, the numerator is a regular exponent. So in this case, if you want to change this into radical form, it's a root of 2, and the base is 9, and then that will get a regular exponent of 3. So here you're asking, what number to the exponent 2 makes 9? And of course, the number to the exponent 2 that makes 9 is equal to 3. And then you still have that exponent of 3 because that's in the numerator. So the second root of 9 is 3, and then the numerator is 3, so that means we still have an exponent of 3. So now give that number an exponent of 3. So 3 to the exponent 3 is equal to 27. All right, next question. 25 to the 4 over 3, so it's a cubed root of 125. And then the numerator is 4, so once you've done that, you raise it to the exponent 4. So what number to the exponent 3 makes 125? And that number is 5, because 5 to the exponent 3 makes 125. Then we still have an exponent 4. Now give that number an exponent of 4. And 5 to the 4 is equal to 625. The last part we're going to be looking at is not only a fraction exponent, but also a negative exponent. So first thing I need you to do is just make sure that that looks like it reads 125, because mine was cut off. All right, now what you want to remember is a negative exponent flips the base upside down. So the first thing you want to do is that negative exponent is going to flip the base. So instead of the base being 81, the base is now 1 over 81. And your exponent will now become positive, so it will become 3 over 4. That's the first thing you're going to do. The second thing you're going to do is the root, which is the denominator. So now you're going to take the fourth root. If you want, you can put it into radical form, Again, you don't have to. But then after that, it'll get an exponent of 3. Some people will just do this part in their head. So the fourth root of 1, so the denominator is the root, fourth root of 1, and the numerator is an exponent. So the fourth root of 1 to the exponent of 3, then the fourth root of 81 to the exponent of 3, fourth root of 81 to the exponent of 3. So what number to the exponent 4 makes 1? That's 1, and then there's still an exponent of 3. And what number to the exponent 4 makes 81? That's 3, and then it still has an exponent of 3. Then the last thing you're going to do is to now do these exponents. So 1 to the exponent 3 is 1, and 3 to the exponent 3 is 27. And we'll do one more example. So the first thing is the negative exponent will flip the base. So instead of the base being 8 over 125, it will be 125 over 8. And the exponent will now become positive 2 over 3. Now, this part is optional. If you want to put it into radical form, so now we're finding the third root. So the third root of 125 and the third root of 8. But then of course these will still have an exponent of 2 afterwards. So the third root of 125, what number to the exponent 3 makes 125? That's 5. The third root of 8, what number to the exponent 3 makes 8? That's 2. And then each of these still has an exponent of 2. And then lastly, here we have an exponent of 2. So 5 to the exponent 2 is 25, and 2 to the exponent 2 is 4. So that is how you work out fraction and fraction exponents. I just want to remind you, rational just means fraction, but the only difference between a rational number and a fraction is fractions usually just indicate that they're positive, whereas rational indicates that they could be positive or negative. So the exponent could be negative, there could be a numerator, there could be a denominator. So in this case, the first thing that you would do, just to make your life easier, you can do them in any order, but this just makes your life easier. So the first thing you're going to do is flip the base. It just makes your life a little bit easier to do them in this order. Then the second thing that you would do is take the root, which is the denominator of the fraction, and then the third step would be whatever the numerator is, that's the exponent. So sometimes there's no negative, sometimes there's no numerator other than 1, sometimes there's no root, but if there is, that would be the order that you would do things.